Hey there, welcome back to our channel, where we explore the realm of technology. Deep learning has emerged as a powerful technology in artificial intelligence, transforming various industries and driving innovation. It has gathered attention for its exceptional ability to learn directly from data, extracting meaningful representations and patterns without extensive programming. In this video, we'll be demystifying the buzzword that is deep learning, and providing an intuition of how it works. So, without further ado, let's get started. So actually, what is deep learning? Deep learning is a subset of machine learning that trains artificial neural networks to learn and make predictions from complex and extensive data. Unlike traditional machine learning algorithms, deep learning models utilize multiple layers of interconnected neurons to automatically learn hierarchical representations of data. This allows them to extract features and intricate patterns from raw input data. Deep learning models efficiently learn directly from raw data without needing manual feature engineering. They have the ability to handle unstructured data such as audio, images, and text, and have achieved phenomenal performance in tasks such as natural language processing and image and speech recognition. The impetus behind deep learning success is the use of neural networks, which are computational models inspired by the function and structure of biological brains. Neural networks are composed of interconnected nodes called neurons, organized into layers. Each neuron takes input from the previous layer, applies an activation function, and passes the output to the next layer. Deep learning models can learn to make accurate predictions by adjusting the strength of connections between neurons. Now, we'll demystify the basics of neural networks and their role in solving complex problems. Neural networks are the critical components of deep learning. To understand deep learning, it is vital to grasp the basics of neural networks. At its core, a neural network comprises layers of interconnected neurons that process and transform input data. Neurons are the building blocks of a neural network. Each neuron takes a number of inputs, performs a computation, and produces an output. The output is based on an activation function, which introduces nonlinearity into the network, allowing it to model complex relationships in the data. Neurons are structured into layers. A neural network generally consists of a single input layer, one or more hidden layers, and an output layer. The input layer receives the raw data, and subsequent layers process the information to make classifications or predictions. Connections between neurons are represented by weights. Weight determines the strength and influence of each neuron's input on the output. Each neuron also has an associated bias that allows it to capture additional information. Activation functions bring nonlinearity into the neural network, allowing it to learn complex relationships. Standard activation functions include tan, sigmoid, and rectified linear units. Now, let's delve into the process of training neural networks. Training a neural network consists of optimizing biases and weights to make precise predictions. This process is typically achieved using a procedure called backpropagation. Backpropagation calculates the gradients of the loss function with respect to the network's parameters and modifies the biases and weights accordingly. Data preparation. To train a neural network, data must be prepared properly. This involves pre-processing steps such as standardizing the data, handling missing values, and dividing the dataset into training, validation, and testing sets. Forward propagation. In forward propagation, input data is fed through the network, and computations are carried out in each layer. The output is compared to the desired output, and the difference is calculated using a loss function. Backpropagation. Backpropagation involves propagating the error backward through the network and adjusting the biases and weights in each layer to minimize the loss function. This iterative process continues until the network's performance reaches an optimum level. Optimizers and loss functions. Optimizers control how the network's parameters are updated during training. Popular optimizers include ADAM, stochastic gradient descent, and ARMSPROP. Loss functions quantify the discrepancy between predicted and real outputs. Deep learning has shown exceptional performance across various domains and has revolutionized multiple industries. Let's explore some of them. Computer vision. deep learning models transcend tasks such as object detection, image classification, and segmentation. They have enabled breakthroughs in areas like medical imaging, autonomous driving, and surveillance systems. Natural language processing, deep learning can be used to analyze and understand human language, enabling applications such as virtual assistants, chatbots, and voice recognition. Recommender systems, deep learning algorithms fuel recommendation engines, enabling personalized recommendations for movies, products, music, and more. These systems assess user preferences and behavior to suggest relevant items. Autonomous vehicles, deep learning is essential for autonomous vehicles, allowing them to perceive and understand their environment through sensor data and computer vision analysis. It helps with tasks like lane recognition, object detection, and decision-making. Healthcare and medical diagnostics, deep learning has made noteworthy strides in healthcare, aiding in disease diagnosis, medical imaging analysis, drug discovery, and personalized medicine. Now, we've come to the most important part of our video. How to learn the basic concepts of deep learning. Besides foundational knowledge in mathematics, a deep learning expert must possess good programming skills and a decent understanding of all the concepts in machine learning algorithms. That's because machine learning models are less complicated than deep learning algorithms. For basic programming skills, we suggest you learn Python. A book recommendation for that is Python Programming for the Absolute Beginner by Michael Dawson. This book contains exciting games and fun exercises to make learning enjoyable. It will guide you in implementing loops, various data types of variables, statements, OOPs, and data file handling in Python. It also contains a chapter on sound, animation, and program development in Python. Understanding Machine Learning, From Theory to Algorithms by Shai Shalev-Schwartz and Shai Ben-David is a good pick for learning about machine learning models. The book starts with the basics of mathematics and then explains the machine learning models in detail. One of the best things about this book is that it gradually builds up the momentum from theory to practice. And there you have it. Deep Learning Demystified, Step by Step, for Beginners. Deep learning is a powerful tool that has the potential to transform a wide range of industries and applications. While it may seem complex and intimidating at first, with the right resources and guidance, anyone can learn the basics of deep learning and start exploring its possibilities. We hope this guide has been helpful in your quest to understand and harness the power of this exciting field. Don't forget to like, share, and subscribe for more insightful content on our channel.